Hello everyone, welcome to Clashing Coder. So in this video we'll see the question that is leaders in an array. So this is an easy question, but it has been asked in various interviews for you can see these companies, that is Amazon, PayU, Samsung, and also sometimes in Microsoft and Google. So this question is really simple. It is not such a difficult question to solve, and it is related to array. So let's see. Given an array of positive integers, your task is to find the leaders in the array. So and note, an element of an array is leader if it is greater than or equal to all the elements to its right side. So also the rightmost element is always a leader. So that I will explain you what it means. Let's see. So yeah, so you can see this is the input that we're given, and in this input, let me change the marker. So the leader, we have to find the leader from this array, the elements which are leader. So leader is an element which has all the elements on its right side as smaller. You can see for this 7, you can see this 7 is greater than all the elements on this side, and it is also equal to 7. So you can see it is written that number of here you can see greater than or equal to. So this equal to also counts. So that means this 7 is a leader. So this 7 is a leader here. But if you see this 4, this 4 is smaller than 5 and smaller than 7. So it does not have any all the elements that are smaller than it on the right side. That means it is not a leader. So 4 is not a leader. And it is also written that the rightmost element, that is this 3, is always a leader, because the rightmost element does not have anything on its right. So it is leader of itself, so it will be the leader. So therefore we have to find all the leaders in the array or in the given array. So the leaders in the array would not be equal to the size of the array. It can be anything, like there can be one leader, there can be two leader, or all element can be leader if the array is sorted in like sorted into decreasing order. So let's see. So you can see the input, the first line of the input contains the t, that means test cases, and the second line that will contain the numbers, the number of elements in the array for the particular test case, and the array elements in the next line. So we have to print all the leaders, and you can see the constraints also. So constraints are not that large. This can be stored into an int. You can see these values can be stored into an int. So these are the test cases. In this test case, you can see 3 are the test cases, and this is the number of elements 6, and these are the elements 16, 17, 4, 3, and 5, 2. So for this, you can see the leaders will be, this 2 will be always leader because it is on the right side, and you can see 5 is also leader because it is greater than 2. Then you can see this 17 is leader, but this 16 is not the leader. So you can see 17, 5, and 2. So let's see. So the naive approach, if the interviewer asks you this question in the interview, so the naive approach that you can tell him about this problem will be simply running the 2 for loops, because you have to find the element which is leader, and for doing that you will have to check all the elements on its right side. So if so we can simply use 2 for loops to see that. So I've written the pseudocode also here. You can see this is a pseudocode, so I will explain you. So you can see if we are searching for we are checking if this element is the leader or not. So we will have to traverse the whole array after that element, that particular element, and you can see this will be the array that we have to check, and we will check if all the elements in this array after this particular element that we are on is less than this. You can see there 17 is not less than 6, so that means this cannot be the leader. But if we are on the 17, actually if we are on the 17 and we are checking all the elements after 17, and we will check if there is any element greater than that. So no, there is not any element greater than that. So that means 17 is the leader of this particular array in this particular point. So that is what we can simply do, and I have written the pseudocode. You can see from here. You can see I will run from 0 to n, because we have to check for all elements. I will be from 0 to n. It will start from here and it will run till here. And then you can see we will have to initialize the j as 0. We will initialize j out of the for loop because we need to check the value of j. So I will explain you how. You can see the simple solution will be like we will run the element for, if we are on this element, this 17, I will be here. J will be running not from I, it will be running from I plus 1, because we have to check all the elements after that particular element. And we will keep running this loop while all the elements are smaller than this. If we get any element, like for this 17, if we get here we have like 31, so 31 will be greater than 17, so we will simply break the loop. So loop will be broken. Okay, loop will break here, then j will be left here. So if you see now, j is not equal to the size. If an element is leader, its j will always reach to the end point, because there should be no element greater than that. But here you can see j break before the n, so you can see j is not equal to n, so that means we will not print this element. This is not the leader. But for 7, you can see here it was 3, so j will keep running till all the elements, because this will not break. A of I is not less than A of j. A of j is always less than a of j is this 4, 3, then 5, then 2. They're not less than this. So j will reach till this point, which will be equal to n. So if you check j is equal to n, so it means that this is a leader. So we'll simply print that element. So now, well, this solution will work, but it will be not a good solution. But in an interview, you can start with this. You can see the time complexity for this will be O of n square and the space will be O of 1. But now let's see how we can optimize this further. But if you see carefully, we are traversing from left side, but we need to check the elements on the right side. So that will be not efficient. But why not we traverse from the right side, reverse way? Because you can see, for finding if an element is leader or not, why we have to check for the rightmost elements. So that is why we will start traversing from the right side. If we traverse from the right side, if we traverse from this point, this 3, so we can simply print this 3 because this is the rightmost element. If I is equal to n, because you know it is the leader of itself, then what we can do is we can simply say, make a variable that will be max variable, and we will maintain the max for the particular point. And you can see, though for max, now max will be 3 because this is the starting element. Now if we are on this element 7, now if you see, we can check the max element on the particular side is less than 7. So that means 7 is the leader of itself, because there is no element that is greater than 7. Max is at most 3, so 3 is less than 7. So if you see for 5, now you can see when we go to this index, when we come to this index, this will be updated. It will be 7 because max is 7 now. So now if you see, we have the max out of these elements after 5. So if we simply get the max out of this element, so we will compare this max with the element that we are on. So 5 is smaller than 7. So you can see 5 is not the maximum is 7. So that means 5 is not the leader of itself. So we'll simply not print it. So this is what the condition we will be using to optimize our solution. So now let's see the pseudocode for this. You can see I've written the pseudocode here. So we will simply initialize a max variable, and for any element, like for example, if we are on this element 17, okay, we are on 17th element and we are traversing from this side, okay, the rightmost side, right to left. So if we are on this element, we will have the max value. So out of this max value will be 5. You can see max will be 5. Now if you carefully see, all the elements will be less than 5 or equal to 5 because it is a maximum out of these. So if we are on this element, we have to check for all the rightmost elements out of they all should be smaller than this element. If we have the max out of this, so we can simply compare the max with a particular element that we are on. If max is less than this element that we are checking for, it should be the leader because it is greater than the max value out of all the elements that are on its side. So it will be the leader. Now if you see, if we are on this element, I is at this point, if you see I is at this point and the max will be 17. If you see, max will be 17. Now all the elements that are present on the right side of the 6, the max will be 17, but 16 is less than 17. So that means 16 cannot be the leader. So it will be simply not the leader. So this is the technique that we'll be using. So you can see, we'll initialize a max as 0. Then we will traverse the array from n-1 to 0. I will run from right to left. Then at every point, we will check if this value is greater than the particular element value is greater than the max. So we will update the max and print that element, because if the element is here, you can see at this point the I is here, so this 5 will be greater than max. So that means the 5 is max, so 5 is the leader. So we'll print the 5 value and we will update the max also, because our max is increased to 5 from 2. So that is why we will update it to this. So this will be way more efficient than that previous solution, because here we are using simple one loop and we are traversing from right to left, and we are just using of one space because we are using this max variable and we are keeping count of the max value, and for every element we will compare it with max. If it is less than max, it cannot be the this value, the leader. If it is greater than max, so we will update the max, and our current the value element that we are checking for is the leader simply. So for this also you can see the max for the I will add a max here. You can see if I is here, the max will be 2 and it will be the leader because it is a large element. You can see max is 0 and the current element is 2. It will be greater than max, so it will be updated and it will be printed. Now if you check 5, so if we are at here, you can see 5 is greater than 2, so that means it is also the leader. We will update the max to 5 and it will be printed. First 2, then 5, they are printed. Now if you check 3 is not greater than max, so that means we will not print it. This condition will be it will come on the next iteration. It will come here. 3 is not the leader and the max value is still 5, so 5 is still greater than 4, so 4 is also not the leader, so it will iterate to the next element. So you can see now 17 is greater than 5, so 17 is greater than 5, so that means there is no element greater than 17 on its right side, so that means 17 is the leader. So we'll print it and update the max to 17. You can see it will be updated to 17. Now we are at 16. So if you see 16 is not less than it is less than 17, so that means it cannot be the max element or it cannot be the leader, so we will simply not print it. So this solution will take just O of n time because we are traversing from right to left, and it will take O of 1 space because we are simply maintaining the max variable. And if we compare, if we are using the output array, then if we count it, but we usually don't count it because output array we can simply print it simply. So let's see the code on the Geekswiss platform. So actually I've written the code in C++. I hope you will understand it, and I will also share the code in the description. So you can see as we have to first of all take the input this test cases, then we will run while test t minus minus, so it will run for all the test cases, and this is the code that we have to see. So first we will input we will initialize this n, the size of the array, then the max variable. So we will initialize a max to int of minimum. Here I initialized it with 0, so that was you will have to initialize it with the infinity, the minimum infinity, so it will be smaller than all the elements that will come. So you can see we have taken the input size of the array, then we have initialized two arrays, vectors actually. So first will be the input array that we have to intake, and then the result. So here we have to actually we will print, first of all we will get the result because we have to print in the order the elements are occurring. So the 17 will be printed first, then 5, then 2. The method we are using here will print first 2, then 5, then 7. So we will have to save them into a vector. We will save them into vector and reverse that vector. So if we reverse it, so it will be simply that becomes 7, 5 and 2. Then we can simply print it. So that is what we have to do. Then we will input the array elements. Then you can see this is the main condition or the loop that we will be using. So I will run from n minus 1 till I is greater than or equal to 0. Then it for every element it will check if this is greater than the max value that we are having. If it is greater than, then we will update the max, and the element that is greater than max is the leader of itself, so it will be added to the result array or the vector. Then what we'll do, when this condition will end, we will have to reverse this. So instead of reversing, we can simply use this using the STL C++ STL. You can see, so let me zoom in. So you can see we will start from auto result dot r begin, so it will be right begin, so it will be starting on the right side, that is here, and r dot end, it will end here. You can see it is a iterator of type auto. You can see it will automatically take the type. Then it will be starting from the result dot r begin. R begin will be the right side, and the r end will be the left side, the left mode or the 0th index. So we will simply do I++ and print the LU, and don't forget to put this asterisk sign, so that then after that for every test case we will have to put some space also. After that on the next line it should print the output on next time. So that is why we will at the end we will simply see out this, then result of 0 return. So let's see and compile the solution. So actually Geekswiss platform is really good, but it is a bit slower. So let's submit this. So actually I will provide the code in the description, so you can refer it from there also. So it is submitting. So you can see it is, so you can see our solution got submitted successfully, and it took 0.75 seconds. So you can see this solution was very short as compared to the first solution that we were using, but it was also simpler than the brute force solution. So I hope you like this video and you find it useful, and it will really help you in the interviews also. So thank you for watching guys. Do subscribe this channel and like this video and share this video. Thank you for watching guys.